We're talking to Rao Mulpuri, the CEO of View Dynamic Glass, based in California. My first question is about the growth that you've been able to have just in the few years since View was founded out of Solidigm. You've reached the 100 project mark, I think you published just last week, and been included in projects that are very well reviewed, like the NASA Sustainability Base, like really landmark projects. What's enabled that kind of growth?
Well, I think it's the product and the way we built the company. The company is now 7 years old. We spent the first probably 3 or 4 years just focusing on building the key pieces needed for the product. When we looked at this space, we knew instantly that this is a highly desirable product. Except there's been about 50 years of knowledge and work that's been done in trying to bring something like this into commercial scale. If you look around us, there's transition sunglasses, photochromic sunglasses. There's electrochromic rearview mirrors in the cars, electrochromic sunshades, global green line. So there's a number of things that give us inspiration into thinking, what if we could do this for building buildings? And people have attempted those. That need has only grown in that we're building buildings with more and more glass, driven by people's need to stay connected with the outside in terms of views and light. And we're also more lately focusing on sustainability in terms of how do we make our buildings more efficient. And there's a clash between the two. You build with a lot of glass, you bring a lot of heat, and now the building becomes an energy hub. So the need for this has only grown over the years, while people have been attempting to bring something like this into commercial scale. So we looked at that opportunity and we said, okay, do we think we uniquely have the ability to go attack this? And if you look at our team, we come from the semiconductor industry, from the glass industry, from display industry, from thin film solar industry. And we said, what have we learned in terms of specifics, in terms of technology, but also skills in various areas that we could attempt to solve the type of issues that have plagued this industry for a long time. And we broke it into 4 key areas. Performance, which is what's the aesthetic and energy performance that's needed. Size, what's the minimum size needed? As you can see here, we're displaying 5-foot wide by 10-foot tall glass. Durability, this is the most important thing for a product. This thing has to live in the elements for 50 years. The date I think about is 2064. What's 2064? It's 50 years plus 2014. Right? This thing has to be current and still be working in 50 years. And then ultimately cost. We said, we can make all of that, and if the cost is somewhat unattainable, we would build a niche product, a niche company, and focus on just the high end perhaps. But we said we want to make this widely adaptable. So to do that, you have to get all 4 things right: performance, scale, durability, and cost. And what we did different, to answer your question, is we went and met with 170 architects in the first 6 months that we started working on this. We got input from them, like, why would you do it? What would inspire you? Why would you not specify it? What would be issues? We met with builders, we met with developers, we met with corporate real estate folks. We took all that input and drove our products back. From a technical point of view, I think we had a little bit different approach than perhaps anyone else in the space. As I mentioned, semiconductor is core to the company in terms of the people and the DNA. We took a lot of techniques that are common in the industries we came from and applied it to this product. And we leveraged a lot of partners. If you look at the equipment we have in our factory in Olive Branch, Mississippi, it comes from major equipment suppliers in those industries, in the glass industry, in display industry, in thin film solar industry. So we leveraged the capability that was already there and adapted that equipment, those processes and materials to these needs. And we designed the whole system from the ground up to be able to address the fundamental issues that have plagued people from being able to achieve those things. And then we layered on top of it the things we take for granted today. For example, a telephone today is already used as GPS, is used to be able to search and use as a computer. What else can we do? Well, today in your home and office, you can control the thermostat with your phone, you can control the lighting with your phone, you can control your security with your phone. Why not your Windows lighting? So we don't have to buy a new phone, use the same. We have an app that drives the connectivity, drives the condition of the window. So we can make it fundamentally more intelligent. So those are the things we've done. But as I said, it's the strength of the product that drives the excitement and the widespread adoption. And we're seeing that. We're in universities, we're in hospitals, we're in hotels, we're in corporate buildings, we're in government buildings. It's because of the strength of the product and providing the key benefits people are looking for.
You mentioned cost. That's one thing I wanted to ask about because it is true that dynamic glass costs more, but it also obviates certain things in terms of size of HVAC systems, shades, etc. Can you speak to that a little bit?
It's a good question. So cost-wise, yes, it does cost more money. It has more function than regular static glass. But if you think about a dynamic glass unit, what it replaces a static low-E glass unit one-to-one. So because you put this, you don't need that. That's obvious. It replaces everything around the window that you had to design to address the heat and glare issues. Blinds, curtains, shades, canopies, outside blinds, motorized outside blinds. All of that complexity goes away, which, by the way, is desirable anyway. Who likes blinds? Right.
Right.
And then
here's this beautiful view, but we need to cover it half the day.
Exactly.
Yeah.
So now you get rid of that. That has capital savings up front that you can apply to this. And then thirdly, because we reduce 25% of HVAC peak, it has benefits at the grid level because grid peak is same as HVAC peak. But importantly, at the building level, it has benefits at the building infrastructure level. The HVAC systems in the building are designed for that hottest summer afternoon in any given year, right? And because you don't want to be cooking when it's hot outside. So we over-design our HVAC systems to be able to address that time. If you can now cut that down by 25%, I can shrink the chiller units, the fan units, the ducting, the entire infrastructure by 25%. Again, why do you have the HVAC system? The reason you enjoy it is you're able to stay comfortable. You're happy to make that a quarter smaller than it is.
Sure.
Between those two things, so basically it's displacing three: the window coverings and treatments, and a portion of the air conditioner. In many cases, we're able to provide most of that upfront cost from those three things.
And if you can shrink mechanical systems and things like that, you actually gain space as well.
Exactly. Again, the HVAC system is not generating rent for you. Right. It's the space in which you have people that's generating rent. And yes, no tenant comes in and says, I just want to see the biggest duct, and I'm happy to pay $5 more per square foot. No. So yes, shrinking that gives you more space, more usable space, less things.
Right. Are there any current obstacles right now in terms of continuing the adoption and the growth that you've seen?
Fundamentally the biggest thing is awareness. One is people to know that we exist and such a thing is possible in 2014. And the second thing is know that it's available and ready for scale in the type of buildings that they might be building. There it needs a little bit more work. They need to come meet us at a place like here, see the big glass, come and visit our factory so they are confident in our ability to deliver on time to the project, because it's very important that people keep their projects on budget and on schedule. And then know that we've done the work needed to ensure that this is fundamentally durable for that application. Right. So once people get past those, they're very comfortable with the company and the product. So our challenge is to drive this adoption by building awareness, and that's why we're here at AIA. And we're going to be at more shows locally and nationally to be able to spread the awareness. But importantly, a lot of the impressions people have is that this is a technology of the future. Oh yeah, I heard about that. Oh, I watched that in a movie. And in fact, worse is somebody came and pitched me that 5 years ago, and when we actually went and looked, it was some toy window and wasn't ready for me, right? Or the cost was unattainable, or it didn't look quite as good aesthetically. So I think it's overcoming those kind of perceptions people may have that it is ready, it's really ready for prime time. And we're the first company in commercial scale. We hope to see more people in this space, and I think there will be. And the general awareness will be built. The key is to do it faster.
Sure. Where is View manufacturing?
So we have our manufacturing plant, which is absolutely state-of-the-art. It's in a town called Olive Branch, Mississippi. It's a suburb of Memphis, Tennessee. We're right at the state line between Mississippi and Tennessee. It's a 300,000 square foot plant. We've invested close to $100 million in building it. We have over 200 employees. We run this plant round the clock, 7 by 24, 4 shifts. We are very proud of our manufacturing line because this is a physical product. It's sophisticated technology. We took a lot of painstaking care to build it right and to make sure we can, as I mentioned, support our customers where we not only deliver on time, but we have all the quality systems in place to be able to make sure that it arrives at the right quality and performs well on day one, but continues to perform as we scale and as the customer uses this product.
Was it tough from an economic standpoint to choose to keep manufacturing in the U.S.?
Not at all.
Priority?
Not at all. As I mentioned, this is a fairly sophisticated technology. While we did our R&D in Silicon Valley, we knew manufacturing had to be somewhere onshore here. Fundamentally, a couple of reasons. One is there's what's called yield, which is when we start 100 pieces of glass at the beginning of the line, how many of them end at the end of the line. If your yield, for example, is 50%, the cost is essentially double if it was 100%. So there is a big level of cost. So we knew that having it close to where we've done R&D, having it in places where we have a high confidence in being able to ramp the yield, put the capabilities in place to produce the quality product is going to be the biggest level for cost. The second thing is the glass doesn't travel very well. Look at this unit. This thing weighs about 300 pounds. Right? You don't want it. No, it won't. It's very well secured, much the way commercial windows are secured. But they don't transport very easily, although with containerized shipping and cost of shipping at a reasonable level, you can actually move these around. Quite a bit of glass moves around the world. But if you break one of these at the job site, you want the piece of glass to be replaced as quickly as possible. And we can make custom sizes with 1/16 of an inch increment, literally 1.3 million different sizes in rectangles alone, from 14 by 14 inches to 60 by 120. So we can make you the makeup and the size you want fairly quickly and deliver the replacement. It would be hard to do if you have planned overseas with 8 weeks on a ship and customs and so on. So for those two reasons, we chose to build our plants here. As we grow in North America, we're going to build more plants right here.
What's the largest project that you
The largest project in which we have delivered glass and installed is a 1.8 million square foot hospital called the Humber River Hospital in Toronto. It's all the glass is delivered. It's still going through its final construction phase. The building will be occupied next year.
Okay.
We have 27,000 square feet of dynamic glass in that project. The biggest project we shipped our glass to is CenturyLink's headquarters complex in Monroe, Louisiana. It's a 300,000 square foot building, a smaller building, but it's basically all glass. And it's a technology center where all the glass is from Vietnam. That's 37,000 square feet of dynamic glass. Now these are record-setting numbers for dynamic glass. Obviously,
just
as an industry, but for glass industry, obviously, there are towers that take 200,000-300,000 square feet per building. Okay, we are now working on this. We are working with developers, we're working with corporations, we're working with people that are now taking it seriously where, perhaps you can deliver and make me successful at executing our project. So we're building capacity. The plant we have in Mississippi can ramp up to 5 million square feet a year. So clearly we can do a number of projects that are hundreds of thousands of square feet. And as I said, the pipeline of projects we're working on have some of those, going forward. Of course, we're going to do the 10,000 square foot jobs, but we're also looking at 100,000, 200,000 square foot jobs today.
View is a founding member of the Building Health Initiative, right? How does dynamic glass affect indoor occupant health and the health of indoor buildings?
Great question. Traditionally when people thought about sustainability of people, they've looked at what the materials are. They've looked at what's the recyclability of the material. They've looked at what energy did it cost to make and transport it to the job site. How did you put it together in the building? But I think more and more the focus is actually being added, if not shifted, towards the occupant. And the health and sustainability of the occupant depends obviously on a number of factors. The quality of the air, the quality of the environment, the audio quality, which isn't great right now here with all the people around our booth, but also around the connection they have to the outside, the views and natural light. So we call that the vitamin aspect. We all love the windows. We all love staying connected to the outside. In fact, bunkers are much more energy efficient than the glassy buildings we build. but we go crazy after a few
Right.
hours.
We should all be underground right now. But we're not.
But we're not for a reason, because we're humans, we're built a certain way, we have these circadian rhythms, and we love being connected to the outside, and this product provides that from a health point of view. The aspirin aspect is heat and glare are really negative for us. We don't perform well when you have to go like this and you can't see what's in front of you. You don't perform well when you're thermally uncomfortable or maybe sweating at the edge of the building. This provides some benefit there. We also signed on to provide full disclosure of all the materials that go in, not only during glass processing in our plant, but all the parts that we supply, the connectors, the controllers, the wiring, the apps, everything put together. So you have complete transparency around what you're getting as a user. And that's where the industry's headed. We're leading that through this Building Health Initiative with the 20 or 30 people that have signed on to this, architects, developers, builders, and some product manufacturers. Dynamic glass itself, it's definitely more sustainable from an energy point of view. It's definitely more healthy from an occupant feeling and comfort point of view. And yes, in terms of how we manufacture it, we've taken a lot of care to make sure we build a plant the right way, we treat our people the right way as we manufacture it, and certainly how it's done.